So for this lesson, this is the second side of the worksheet. We are going to look at 13, 20, and 35, as I think those give a good synopsis of the overall ideas of what we see here. So if you look in the upper right-hand corner, we have the sample space for these problems that go up to 32. This right here is a sample space where we look at the rolls or the numbers that would come up on an individual die. So this is the die 1, rolling a 1, 2, 3, 4, 5, 6. The second die rolling a 1, 2, 3, 4, 5, 6. So if I roll both of them at the same time, this one right here is rolling a 1 with the first dice, 2 with the second. This, for instance, would be rolling a 3 and a 3, and so on. If we add them up, 1 plus 1 is 2, and that's what this means. The 1 and the 1 gives us a 2. If I pick another one, 3 and 4 adds to 12. So if I go to the 3 and 4, oh, I'm sorry, not adds to 12, it adds to 7. I multiplied. So 3 plus 4 is 7. So if I come over here, the 3 and 4 is 7. So both these sample spaces mean the same thing, but can accomplish different things depending on how the question's asked. So for number 3, when it says one die is less than or equal to 3, we're going to make a assumption. What that means there is I think that problem could be specified more, but I take it as it means that we're just saying one of the die less than or equal to 3, not like this die, like the first die being less than or equal to 3 and the other die being less than or equal to 3. We just mean like one of them. So if we just think of it as one of them being less than or equal to 3, let's look at the first one. So if, let's say, the first die could be 3 or less, that means what's the probability of the first die being rolled at 3 or less? That would be all of these up here, right, if I fill that in. And if we look at that, that would be 3 times 6, which is 18, and that's out of 36, which is obviously 1/2. Okay, not too big of a deal on that one. Next, we're going to look at 28, where when they talk about the first part of it in 28, if you look at the first part of 28, it says one die is greater than or equal to 4. So we're assuming that's talking about either the first die or the second die, but not both. So one die greater than or equal to 4. So I'm just going to make that the first die is greater than or equal to 4. So that'd be 4, 5, and 6, and these would be all the possibilities, 4, 5, and 6. And then we're looking at one die equaling exactly 4. So that means the other one. So that's kind of the assumption we're making when we're talking about both of them. And it says and. And when it says and, that means it has to be both of them at the same time. So if I first just fill in this right here, now I look at where is the overlap, because both of them have to be true at the same time. And where they overlap is these 3 right here. So that is when the first die is 4 or greater and the second die is exactly equal to 4. So that would be 3 out of 36, which will give us 1/12. So I actually am going to do one more. I'm going to add 27 onto this, as I like to, in this video, do an and problem and an or problem. We already did an and problem in 28, so now we're going to move to 27. If we look at 27, it says probability of rolling one die less than or equal to 2, so let's go ahead and highlight that. First die less than or equal to 2, so that would be 2 or 1. So if we look, that gives us 12 altogether. Just keep that in mind. And then the second one die less than or equal to 5. So the other one has to be 5 or less. And if we do that, we end up filling in all of that. And what's interesting is that there's an overlap. So what happens is, look, I'm going to color the blue over that. Even though this doesn't match up with Ray G. Biv, let's color in the overlap is green. It's interesting, actually, it did create purple there. I didn't know that these overlap with each other and actually did the correct colors. Pretty cool. So in any case, that overlap's really important, because what happens is if it's blue or red, those we're going to add together because they don't have to be true at the same time. So if I take the red, there's 12 of them. Then I'm going to add that to the blue, and the blue is a 5 by 6, which is 30. The problem is when we add the red and the blue, we add all of the green twice. We added it when it was red, and we added it with this blue. We only want to add it once, so we need to subtract one of them off. So I'm going to subtract off the green. Let's think about that again. If we add those twice, we only want to add them once, so we have to subtract them off all once. So if there's, let's see, 5 by 2, there's 10 of them. We've counted 10 twice, so we simply subtract. So whenever you have an overlap, you are going to count up both of the events, or both of the blue and red in this case, and then whatever the overlap is, you have to subtract it off once. If we do that, we get 42 minus 10 is 32, and then 32 over 36 reduces by 4, so that gives us 8 over 9, so we have an 88% chance that's happening. And we could test that. 32 out of 36 means there should be 4, because there's 4 less in 32 and 36, so there should be 4 that are not included in the event in the numerator, which we see right here. There's 4 of them, so that works, provided that we interpret it in that fashion. I suppose it could be interpreted as one die could be greater than or equal to 4, or the other die could be greater than or equal to 4. I'm sorry, and 27. One die could be less than or equal to 2, or the other die could be less than or equal to 2, as well as the one die greater than or equal to 5. So we're just assuming that when they say the one die less than or equal to 2, it's talking about the first die, and then the other condition on the second die is one die less than or equal to 5. Okay, for number 35, first 3 coins are tossed, excuse me, and we need to create a sample space for that. So when a coin is tossed, possibilities are heads. So if I flip 3 coins, you can think of them flipped all at the same time or successively. First die head, and then second die heads, third die heads, or we could have heads, heads, tails, and now heads, tails, heads, tails, heads, heads. Those are all of our possibility where we have one tail. Now we're going to look at all the possibility when there's 2 tails. That'd be heads, tails, 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 heads, tails, 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 heads, and then one possibility of tails, tails, tails. So we have 8 possibilities altogether. Note, if we did there's 2 possibilities, we could think of it as counting principles, because the event is put back into the sample space. If I flip a heads, I could flip a heads again. If you made a sample space of a dash, a dash, and a dash, and put 2, 2, and 2 in there, we multiply them, that would give you 2 to the third, or 8. So that matches up. This, having it written out is nice, but it also matches up with counting principles. So what's the probability that we have 2 heads and 1 tail? So let's just go through and circle the ones, or highlight the ones where we have 2 heads and 1 tail. So it has to have both of those. So 2 heads, we have that right there. 2 heads, 2 heads, and that's it. That's 3 out of 8. And so 3 out of 8 would be your answer.